Just like organizing your inventory or color-coding your calendar, setting up your network properly saves time and prevents headaches. One-to-one VLAN mapping is a simple way to bring order to your digital traffic. It's used to match and translate VLANs, virtual local area networks, between different parts of a network. This is important, especially when they use different VLAN numbers or when connecting networks from different organizations or service providers. This keeps your network organized, prevents accidental mix-ups, and makes sure only the right devices can communicate with each other. To illustrate, think of your network traffic like cars going down the freeway. VLANs are the special lanes marked for certain vehicles. When set up correctly, a car in the red lane on one highway keeps traveling in the red lane after switching to another highway, even if the lane numbers change. If you would like to learn more about the basics, click the link in the description. In this episode of Cisco Tech Talk, I'll show you how to configure one-to-one VLAN mapping on a Catalyst 1300 switch using the command line interface, CLI, next. Let's begin by looking at the networks involved. In this demonstration, you'll see two different networks. The first is a customer premises equipment, CPE network. The second, a provider edge network. I'm using VLAN 9 on the CPE side. I'll translate that to VLAN 11 as it crosses into the provider's network. On the other side, it will switch back to VLAN 9. This lets devices talk to each other, even though the VLAN numbers change in the middle. The first step is to set up the ports. I'll focus on the port that connects to the provider's network. I'll configure this as a trunk port so it can carry multiple VLANs. Make sure there's no native VLAN. Otherwise, there could be errors if the other side doesn't use one. Setting native VLAN as none helps avoid mismatch issues, which can cause problems in communication. Turn off smart ports so the ports aren't automatically set up. It can cause issues as well. To demonstrate, I'll configure another port as access port for VLAN 9 and connect it to a PC. This access port is simpler. It only carries one VLAN, making it easy for my PC to connect. Now I'll move on to the provider equipment switch and create any needed VLANs. Disable IP routing, which stops the switch from acting like a router. This is important for VLAN mapping to work correctly. Before I start mapping VLANs, it's important to check your available resources. Every time you set up a mapping, it uses resources in the switch. You can reserve up to 228 VLAN mapping entries. To check this, use the command show system resources and look at the VLAN mapping entries. Right now, there aren't any entries. I haven't set up mappings yet. If you try to map VLANs without allocating enough resources, the switch gives you an error. You see this error here. To fix it, set up a VLAN mapping entry. Allocate enough resources so you don't run into this error again. After making the changes, save the configuration and reboot the device. Once the switch is back online, it's time to verify your settings. The switch shows the right number of VLAN mapping entries. Now you can configure VLAN mapping on a port. Make this port a VLAN mapping tunnel port, which means it will handle the translation between VLANs. Turn off Auto Smart Port and disable spanning tree calculations. They aren't needed for this tunnel. After creating the VLAN mapping, there's no error. That's how you know it's working. Configure the port that connects to the next provider switch. This port is a trunk port, but I'll set it to only allow VLAN 11 through it. That's what I'm translating. I won't allow VLAN 9 on this trunk port. It keeps things clear and organized. Turn off Auto Smart Port on this port. Now this switch is ready, and I can move on to the other two switches. The next two switches are set up in the same way as the first ones. I won't show every step here, but I'll show you the results. The provider switch mirrors the configuration. VLAN 9 and 11 are created and IP routing is off. I've allocated plenty of VLAN mapping entries. Port 1 connects to the CPE switch with the mapping tunnel. Port 2 connects to the other provider switch as a trunk, only allowing VLAN 11. On the second CPE switch, I'll only create VLAN 9. I'll configure the trunk port that connects upstream. Make sure there's no native VLAN and Auto Smart Port is off. I've set up an access port for another PC to test connectivity. Great! Everything should be set. Now test the connectivity between the PCs. One PC has the address 192.168.9.10, and the other has 192.168.9.20. If you see them connect, it means the VLAN mapping is working. The mapping tunnels the connection through 4 switches, translating VLAN 9 to VLAN 11 and back, so devices on VLAN 9 can communicate across the network. That's how simple it can be. Just like a good highway system, VLAN mapping helps prevent collisions and mix-ups. This helps ensure a smooth ride no matter how busy the road gets. Thanks for watching. I'll see you next time.